Alright, this video is going to be our notes about inscribed angles and dealing with their arcs. We need to remember that an inscribed angle is defined as an angle whose vertex, right here, is on the circle. So right in here, an angle whose vertex is on the circle. Okay, so we have this inscribed angle, angle ABC. We need to remember that these angles are going to open up to arcs. So the arc intercepted, or what you'll hear as intercepted arcs, either way, is going to be arc AC. What does the angle open up to? What arc? So here in example 1, we're going to go ahead and label each or name each one of these inscribed angles and their intercepted arc, the arc that those angles open up to. So first we'll go ahead and, doesn't matter where we start, we'll go ahead and just start right here. We've got this angle where the vertex E is on the circle. So this would be angle, remember how to read these, D, E, F, vertex being that middle letter. So we have D, E, F. The arc that it is going to open up to is going to be over here at arc DF. So that as we move around, we'll go ahead and find the next angle. We'll look at the top at vertex D. We're going to have angle EDF. And this inscribed angle is going to open up and intercept arc EF. And our last and third one here in this diagram, right here, vertex F, we're going to have angle DFE. And this inscribed angle is going to open up to arc DE. And what you're going to notice is, if you look at the name of the angles and the name of the arcs that they open up to, that they intercept, are going to be the outer two letters, the letters that are not the vertex. So if you see here, the outer two letters DF, that's what arc it opens up to. The second angle we put was the outer two letters were E and F, and that's where the arc is. And then here, D and E. So when these open up, there's going to be this nice little formula that's going to be, hey, so here's the angle, here's the arc, either one. How do we find the other? So this is the relationship between them. The measure of the angle is simply going to be equal to the arc measurement divided by 2. So you just divide the arc by 2. So let's take a look already at the first one here. We have that we're going to look for the measure of angle DEF. So we're looking for X here. So we know that angle is going to be equal to the intercepted arc of 80 divided by 2. So X is simply going to be 40 degrees. Okay, short, simple, and sweet. Just divide that arc. Now what happens if they give us the arc and we have to work backwards? So let's take a look here. We're going to be solving for X and Y on these problems here. So here, to solve for X first, right here, we want to find this arc. Well, the inscribed angle is going to be right here, that 42. So now we're looking for X, we're looking for X, the arc, which in our formula was up top. So we have our measurement of our inscribed angle now. So the angle 42 is going to be equal to the arc, which is X, over 2. So we just work backwards as we've done before. We multiply both sides by that denominator of 2, so they cancel. What you do to one, you do to the other. And so that X simply will come out to 84. Just working backwards. Now we're going to look at Y. So to find Y, we don't need to actually use this formula. What we have here is we have 2 of the 3 arcs that go all the way around. This one's 84 degrees. So remembering that the circumference measurement is 360 degrees, we need to take the 2 arcs that we have, arc HG and arc GI, simply add those 2 together. We're going to end up with 222, and we just take that away. So we've got these 2 pieces away from 360. We take it away and see what's left for Y, or arc HI, and we wind up that Y is going to equal 138. All right. So our next problem here, we're going to go ahead and find x. So the first thing we have to do is realize that the intercepted arc, okay, is going to be right here. And the problem is that we don't have this arc to plug into our formula. But just like the previous problem, we do have the other two, knowing everything is 360 degrees. So again, we could take this 120 plus the 70 to get our 190 and take that away from the whole 360. Looks like a 66, and get 170. So now we know that this arc that we're looking for is 170. We can now plug that into our formula where we have the measure of the angle, which is x, is equal to the arc, that 170, divided by 2. So we get that our x is equal to 85. All right, so we're bringing in some more algebra here. We're going to do the same thing, set everything up exactly how we plug everything into our formula. We are going to plug in for the angle, and we're going to plug in for the arc. Remember that we have the angle is equal to the arc divided by 2. So the angle right here, 3x plus 24, is going to be equal to the intercepted arc, 108, divided by 2. So the nice thing about this is we don't have to worry about working backwards. We're just going to do that 108 divided by 2, and we'll create our new equation of 3x plus 24 is now equal to 54. And now all we have to do is our two steps in solving for x. We're going to subtract that 24 from both sides, and then we'll end up with 3x equals 30. And then divide, and we've got that x is going to equal 10. I know this problem does say find the measure of angle DEF, but you see we have the wrong letter, so we're just going to leave it at solving for x. All right, inscribed angles now having the same arc. If we have two inscribed angles opening up to the exact same arc, what's going to end up happening is these angles are going to be congruent. Because the arcs are congruent, they have the exact same arc, well, according to the formula, they're going to come down to the exact same angle measurement. So here, angle 1 and angle 2 will be congruent because they share arc BD right here. So we're going to name these two inscribed angles that intercept arc BD. So we're naming the two inscribed angles, which would be angle 1 and angle 2, or we could call it angle BAD and angle DCB. All right, so we need to see where these are, and they open up to this exact same arc BD. So let's take a look at over here. We're going to find the measure of angle EFH. So we're looking right here. So we're looking for x. Well, what we need to remember is that the measure of angle EFH is equal to the measure of angle, here we have HGE. So these being congruent, x is simply going to be 37 degrees. All right, so our last one's going to take a little bit of work here, okay? First, we're going to start off with what we want to find is the measure of arc IJ. So the measure of arc IJ is going to be right here. So we're going to have to figure out what x is first. Then we're going to have to figure out what the angle measure is by substituting it back into one of these, knowing they're both the same. And then we have to use our inscribed angle formula. Okay, so we've got 3 steps here. First, let's start off with let's solve for x. So these being congruent because they open up to the exact same arc, we're going to go ahead and set these equal to each other of 6x plus 3. I think that's actually, let me change that because this ended up coming out to like a negative decimal. Yours says minus. So I didn't get a chance to change that. we've got minus over here, and we've got a plus over here. We need to switch those signs. So here we have 6x minus 3 is equal to the 4x. Now we have a plus 3, or plus 2 on mine. Yours should read that. All right, didn't get a chance to change mine. So, solving for x, I'm going to go quickly. We're going to go ahead and move that 4x to the left, giving us a total of 2x minus 3 equal to just a 2. Let's add that 3 to both sides. So we wind up with 2x equals 5. Last step, divide, and your x is going to equal 2.5. So with this being said, we now need to go into our angles, and one of the two of them, it doesn't matter which one, and we need to substitute in. So what I'm going to do is I'm just going to take this one right here. We're going to take the measure of angle. I've got IKJ. I've got 6. I'm going to remove x, and I'm going to substitute in what x is, that 2.5. And we've got the minus 3. When we go about this, we're going to come out with this angle measurement is 12. So last step we have to take, okay, to find the measurement of the arc is we need to use our inscribed angle formula. I'll go ahead and rewrite it, where our angle is going to be equal to the arc divided by 2. So here we have our angle, found out was 12, so we have 12 is equal to the arc, unknown, over 2. So just like we did in the last problem on the previous page, we're going to multiply both sides by 2 to get rid of the denominator. And then we simply have that, our arc IJ, which I should have put the measure of in front, is going to end up being 24. Sorry for squeezing everything in there. Okay? Again, as always, if you have any questions, please talk to your teacher, or you can research other videos on YouTube titled Inscribed Angles.